Inference about two population proportions. I keep referring to this as 11.1. Just ignore that. That's from a different book. We are just talking about inference about two population proportions. Okay, enjoy the videos. Hey folks, moving on to 11.1, which is inference about two population proportions. Okay, so in 11.1, we're going to use our calculators to do all the heavy lifting. We're going to be using the two prop z int whenever they want confidence intervals. And then the hypothesis test, we're going to be using the two prop z test. So we're going to be using these two functions, whether they want a confidence interval or a hypothesis test. Now, whenever we're using either of these, technically we're supposed to check out the minimum requirements. All of these formulas that we're using magically on our calculator, we always need to check the minimum requirements. You'll notice that whenever I write a problem, I usually say something like assume minimum requirements are met. So that way you can just jump into the problem. But technically speaking, there are minimum requirements. If you go to page 530, it lists them at the bottom there. Number one, the samples are obtained independently using simple random sampling or a form of randomized experiment. Basically, it's just independent, simple random sample. Again, we need to make sure that these things form sort of a bell curve. So make sure that n1, p hat 1, 1 minus p hat 1 is greater than 10, and same with the n2. And then also make sure you're not sampling from too many of the population. Usually we're assuming it's an infinite population, so those don't even come up. But when you're doing the odd problems in the homework, just do these and then go to the back and see that they usually said, okay, they plug the numbers and make sure those work. And then they'll usually give some justification like, oh, it was an infinite population. Or the population was really, really big. Okay. Hey, folks, make sure that you download the most recent 11.1 PDF. So you'll notice there's some formulas up top. We're not going to be using those formulas. We will be using our calculators to do all the heavy lifting for us. Okay, question number one, aspirin and heart attack. Let's assume minimum requirements are met. Is the proportion of heart attacks less in the aspirin group than in the placebo group? Tested the 5% significance level. Okay, so we need our null and our alternative. I keep doing HA. Our book does H1. Most books do HA. Doesn't matter. Same thing. Alternative hypothesis. Okay, the null is always an idea of no difference, no effect. So that would mean that the proportion of heart attacks is the same in the aspirin and placebo group. So that would be that P1 is equal to P2. And our alternative hypothesis is, remember, the null and alternative, the only thing that's different is just the symbol. So this needs to be either greater than, less than, or different. And the book is, or this problem is pretty nice. The first group they mention is aspirin. The next one is placebo. So is the proportion of heart attacks less in the aspirin group, so the first group. So just be careful when you're setting things up. This one was pretty nice. The first thing they mentioned was group 1. So you can switch and call whichever one you want, group 1 or group 2, but just be careful. Okay, so we're wondering if, so group 1, and in this thing we set up, group 1 is the aspirin. Group 2, placebo. Group. Okay. So then we need our, well, just for fun, we don't need to do this, but p hat 1 and our p hat 2. So p hat 1 is our, what we observed, the sample proportion. So in p hat 1, group 1 was the aspirin group. We saw that out of n equal 10564 people, there was 108 heart attacks. In group 2, we looked at 10563 people, and there was x equal 212 heart attacks. Okay, so this is the sample proportion for group 1, sample proportion for group 2. Okay, test that. So now we're going to go to our calculator. It's a hypothesis test. There's two groups, and they're talking about proportions. So we are going to use the 2-prop Z test. Okay, let's see if you can see this okay. Turn it on. We're going to go to Stat. We're going to go over to Tests. We're going to slide down to 2-prop Z test. Maybe a little bit of extra light. Okay, slide down to 2-prop Z test. Enter. It wants the X1, N1, X2, N2. Oh, you mean kind of like we did here? Okay. Should I put a little 1 there? Will that make everyone happy? X1, N1. And this one, I didn't label it. My bad. That was our X2 and our N2. Okay, so let's see. 108. Enter. 10564. Enter. 212. Enter. 10563. Enter. The P1, their alternative is that it does not equal a less than or greater than symbol. Less than symbol, so let's choose that. Enter. Calculate. Okay. So, very similar game to what we've been doing. We understand hypothesis tests. If p-val less than alpha, reject HO. Okay. So it gives us our test stat, which is Z. So my test stat is Z equals negative 5.86, negative 5.8. I just rounded it, 5.9, we'll call it 6. And then, so the test stat, and then they want the p-value. The p-value says 2.333, 2.33 E minus 9. Okay, so that means 0.1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 3. Super duper duper tiny number, so the p-val is really close to 0. And then, so our statistical conclusion, we'll interpret everything in a second. Let's just, right now we're in robot mode. Okay, we got our p-val. How does our p-val compare to our alpha? It says significance level is 5%. So isn't that less than our 0.05, which is our alpha? So if our p-val is less than our alpha, that means we would reject the null. And then our conclusion in plain English, so if we reject the HO, then evidence suggests that the proportion in group 1 is less than in the proportion in group 2. Oh, okay, so evidence suggests the proportion of what? Proportion of heart attacks in group 1. What's group 1? In aspirin group. Proportion of heart attacks in aspirin group is less than proportion in the placebo group. In other words, the evidence is suggesting that aspirin does help reduce the probability of a heart attack. Evidence suggests the proportion of heart attacks in the aspirin group is less than the proportion in the placebo group. Put the word "the" right there. Okay. So let's see. Let's review what just happened. So in our new game, we have the null, 2 groups, and we're talking about proportions. So P1 equal P2, that's kind of a new idea. And then once we have that idea, then we know that the alternative, we just need to figure out what symbol goes there. Is it a less than, a greater than, a different? We're going to plug in all of our data, our X1, N1, X2, N2, into our calculator under our 2-prop Z test. Why Z? Because you can see that formula up top that we didn't use, has Z in it. And that's going to give us a P-value that's really, really tiny, compare p-val to alpha. If p-val less than alpha, reject HO. If we say reject HO, then we say evidence suggests the HA. And then you just put the HA into words. That the proportion in group 1 is less than the proportion in group 2. Okay, more words. The proportion of what? Heart attacks in group 1. What's group 1? Aspirin. Oh, evidence suggests the proportion of heart attacks in the aspirin group, okay, is less than the proportion of heart attacks in the placebo group. Aha. Okay. So that's basically the game, and we'll just keep going with it from there.